Hello. So we've talked about mutually exclusive events, events that cannot occur together at the same time. And we've talked about independent events, events that do not affect each other's occurring. However, we have not talked about the intersection of these two. Can events be mutually exclusive and independent? To explore, I've put all four possible combinations of dependent, independent, and not mutually exclusive, in this 2x2 matrix. Let's start with the upper left, dependent and not mutually exclusive. An example of this would be it snows tomorrow and I have to shovel my car out tomorrow. These are dependent because if it snows tomorrow, I probably have to shovel my car out tomorrow, and if it doesn't snow tomorrow, I probably don't have to shovel my car out. They're not mutually exclusive because they can happen together. An independent and not mutually exclusive set of events would be it snows tomorrow and we have virtual school tomorrow. These are independent because we tend to have virtual school regardless of whether or not it snows. Snow does not affect having virtual school or not. They are not mutually exclusive, however, because they can also happen together. In the upper right, we have dependent and mutually exclusive. Consider these two events. Event A, it snows tomorrow, and event B, it doesn't snow tomorrow. These are dependent on each other, because if event A happens, event B can't happen. If it snows tomorrow, it can't not snow tomorrow. They're also mutually exclusive. They can't occur together. It has to be one or the other. So that leaves us with independent and mutually exclusive events. These can't happen. Why can't events be mutually exclusive and independent? Well, for events to be mutually exclusive, one event occurring means the other event cannot occur. This means that one event occurring affects the other, and so they're not independent. Mutually exclusive events must be dependent. Another way to think about this is in terms of intersections. Mutually exclusive events have probability of an intersection with probability 0. But independent events have an intersection with probability P of A times P of B. So if there's an event that's mutually exclusive and independent, then its intersection has to have probability P of A times P of B, and that has to equal 0. This would require that P of A or P of B be 0. So we can fill out this chart by saying that independent and mutually exclusive events can't exist unless P of A equals 0 or P of B equals 0 or both. But then it's not a really useful distinction anyway, because events that can't occur at all obviously can't occur together. So sure, they're mutually exclusive. And they can't affect anything else occurring or be affected by anything else occurring, since they only have one possible outcome. And so that makes them independent. So that's all for today, but I'm looking forward to seeing you in class. Thank you.